Hello dear students, today we will discuss in numerical method Gauss Seidel iteration method. So this is the working rule Guru Mantra of Gauss Seidel iteration method. This is the step number 1. Whatever I have discussed already in Jacobi method, step 1 and step 2 both are same as we will discuss in Jacobi method. See here, again I repeat this process. Step 1, consider the system of equation a1x plus b1y plus c1z equal to d1 and a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. Here some conditions must be required for finding the values of x, y, z. What is the condition? Modulus of x always modulus of a1 always greater than modulus of b1 plus modulus of c1, modulus of a2 greater than modulus of b2 plus modulus of c2, and modulus of a3 is greater than modulus of b3 plus modulus of c3. So this is the required conditions for finding the value of x, y, z. This is step number 1. Now in step 2, in each equation of the given system, one of the coefficient is larger than the other and thereby satisfying the conditions for Gauss Seidel method. On solving the values of x, y, z of the above equation, we get x equal to 1 by a1 of d1 minus b1y minus c1z. This is equation number 1. Similarly, from second equation, 1 by b2 y equal to 1 by b2 of d2 minus a2x minus c2z. This is equation number 2. And z equal to 1 by c3 d3 minus a3x minus b3y. This is equation number 3. So this is the second steps of working rule. Now third, this is the third step, putting y equal to z equal to 0 in the equation 1 and we get the value of x equal to x1. Now putting x equal to x1, because we are already getting the iteration of x, so taking in the further steps x equal to x1 and z equal to 0 in the equation second, we get y equal to y1. Now what we get? X equal to x1 and y equal to y1. First iteration of x equal to x1 and first iteration of y equal to y1. So putting these two values in the third equation, we get the first iteration of the coefficient z, means z equal to z1. So this is the first result, means first iteration of the equation x equal to x1, y equal to y1 and z equal to z1. What we have done here, initially we put y equal to z equal to 0, we get the first initial value x equal to x1, and putting x equal to x1 and z equal to 0 in the second equation, we get y equal to y1, and lastly put x equal to x1 and y equal to y1, because we have already getting the value of x1 and y1, x1 and y1 in the third equation, we get z equal to z1. So this is the first iteration methodology of the Gauss Seidel method. Now for the second iteration, put y equal to y1 and z equal to z1 in the equation 1, we get x equal to x2. This is the second iteration format. Now we are already getting x equal to x2. So in the next step, x equal to x2 and z equal to z1 in the second equation, we get y equal to y2. We have already getting x equal to x2 and y equal to y2. So put these two values in equation third. This is equation third, not equation 2. We get z equal to z2. Repeat the process in the same fashion until the required conditions. So what is the required condition? Whatever in the questions, getting an approximate up to 3 digit, up to 4 digit, So repeat this process until and unless the required condition of the solution of the equation. Now apply this Guru Mantra in this problem. So what is the problem? Problem is apply Gauss Seidel method to solve the equation 20x plus y minus 2z equal to 17. And the second equation is 3x plus 20y minus z equal to minus 18. And third equation is 2x minus 3y plus 20z equal to 25. So we have taking the equation this one, 20x plus y minus 2z equal to 17, 3x plus 20y minus z equal to minus 18, 2x minus 3y plus 20z equal to 25. Now first we check the conditions. Here from first equation, here the coefficient of x is 20. So modulus of 20 is greater than modulus of 1 minus modulus of minus 2. So this is satisfy the conditions. So easily we can find the value of x and from here. Now from the second equation, see 3x plus 20y minus z equal to minus 18. So the coefficient of y is 20. So 20 modulus of 20 is greater than modulus of 3 plus modulus of minus 1. Here the coefficient of x is 3 and coefficient of z is minus 1. So modulus of 3 and modulus of minus 1. Here also condition satisfied. Now the third equation, 2x minus 3y plus 20z equal to 25. See here the coefficient of z is 20. So 20 modulus of 20 is greater than modulus of 2 plus modulus of minus 3, because minus 3 is the coefficient of minus y and 2 is the coefficient of x. So these three conditions are satisfied. Therefore, when the condition is satisfied, we will find the first iteration. So putting y equal to z equal to 0 in the equation 1, we get the first approximate values as x equal to this one. See 1 by 20, 17 minus, because y is 0 and z is 0. So 17 divided by 20, it becomes like this, 0.8500. This is the x1. Now in the next, putting x1 equal to 0.8500 and z equal to 0 in the equation second, we will find y1 equal to 1 by 20 minus 18 minus 3 into, what is the value of x means x1 is this one and z is 0. So we will get minus 1.0275. Now we have already getting the value of x1 and y1. Now for finding the value of z1, putting x1 equal to this one, 0.8500 and y1 equal to minus 1.027, we get the value of z1. z1 is 1 by 20 of 25 minus 2 into 0.8500 plus 3 into minus 1.0275. We get the value of z1 is 1.0109. So this is the process whatever I have already discussed in the working rule. So this is the first approximate values of the problem. x1 is this one, y1 and z1. Now for the second iteration, put y equal to y1 and y1 equal to minus 1.027 and z equal to z1 1.0109 in the equation 1, we get the value of x2. x2 is 1.0025. Similarly, here we already getting the value of x2. So in the further step, putting x equal to x2 equal to 1.0025 and z equal to z1 1.0109, 0, 1, 0, 9. In second equation, we get the value of y2. We have already the value of x2 and y2. So putting x equal to x2 equal to this one, 1.0025, y equal to y1, y2, and the value is minus 0.9998. In the third equation, we get the value of z2. z2 is 0.9998. So this is the second iterative by Gauss Seidel method. Now for third iterative, put y equal to y2 and y2 equal to minus 0.9998 and z equal to z2 equal to 0.998. In the equation 1, we get the value of x3. x3 is 1.0000. Now we get the value of x3. So in the further step, x equal to x3 equal to 1.000 and z equal to z2 equal to 0.9998. In the second equation, we get the value of y3. y3 is minus 1.0000. Now we have already the value of x3 and y3. So for finding the value of z3, putting x equal to x3 equal to 1.000 and y equal to y3 minus 1.000. In the third equation, we get the value of z3, that is 1.0000. So we have already the value x3, y3 and z3. Since in the second and third iterations give the practically the same values, therefore we can stop here because we get the same values in second and third steps nearly. Hence the solution of the equation, simultaneous equation, is x equal to 1 and y equal to minus 1 and z equal to 1. So this is the process of Gauss Seidel iterative method.